Okay guys, let's take a look at today's lesson. We have been working with right triangles. You know, in geometry you worked with right triangles. We worked with right triangles yesterday. But there are, as you are well aware, there are other kinds of triangles, right, besides right triangles. We need to look at other opportunities. So we have oblique triangles. We have a couple of laws that we're going to learn today. One is the law of cosines and the other is law of sines. So these two laws actually work with any shaped triangle. I mean, it doesn't have to be a right, you don't have to have a right angle in it. You can have any number of angles in it. So let's talk about each of the laws. I'm going to go through the equations and then we're going to talk about when you would use them. So let's take a look at the law of cosines. Let's look at this one first. So referencing this triangle right here, we have c squared is equal to a squared plus b squared minus 2ab cosine c. So a couple things to point out. If you recall from geometry, it's just traditional that we write side lengths with a lowercase letter, right? It's just kind of the norm. We write angle measures with a capital letter. Do you have to? No. I mean, that's just the norm. That's what we typically do. That's the convention. So these here stand for side measures. These are side measures, right? The C and the A and the B. The critical thing about this formula that we really have to kind of focus in on is that this location, this side measure, must be the side opposite this angle. Period. I mean, there's no, it has to be. So this side must be the side opposite of this angle. Okay, the other two sides, it doesn't really matter what order you put them in, that makes no difference. But this is critical, that this location is the side opposite this angle, whatever angle it is you're working with. It doesn't have to be C that you're working, it could be any angle measure or side measure, right? It just they have to be opposite each other. All right, so that's law of cosines. Law of sines. This works in any triangle as well. There's basically some ratios that are set up as proportions. So we have sine of angle A over the opposite side, side A, is equivalent to sine of angle B over the opposite side B, which is also equivalent to sine of angle C over C. This one seems to be easier for students to remember. I guess it's just kind of straightforward, right? It's just a fraction with sine A over A, etc. And the law of cosines, the typical errors that I'll see, there's a couple of normal ones. One is sometimes students forget that this last one is a subtraction. Students usually are fine with the squaring. You know, that kind of looks like Pythagorean theorem anyway. We're used to doing that. But sometimes we may forget this, and sometimes we forget the 2. That's the most common errors that I see when you're memorizing the formula, because you will have to memorize it. We use these formulas, you know, occasionally in calculus as well. So it's just important for you to know these formulas. All right, so that's the formula. So when would we use these? Let's look at the opportunities to use them. So if you have two sides in an angle, like side angle side, or all three sides, then you want to use law of cosines. Basically, if you have more sides than you do angles, you want to use law of cosines. Now, if the reverse is true, if you have more angles, like angle side angle or angle angle side, if you have more angles than sides, you would want to use law of sines. If all you have is angles, we can't solve that triangle. It's impossible. We have to have at least one side. I think you probably remember from geometry that you can prove similarity when the angles of the triangles are are the same, they're equal. You can prove similarity, but you can't prove congruence with just three angles being known. So if you just have angles, we can't solve the triangle. You need more information than that. All right, any questions on the concept before we work a couple of problems? Okay, so let's move to our second slide. This is a calculator lesson. Hopefully you have your calculator with you. And as yesterday with the right triangle applications that we were working on, you really need to have your calculator in degree mode. We're working with triangles. We've got to use degrees. You know, that's just kind of a thing. So in working with these, I highly recommend that you draw the triangle out. Some students just don't want to draw the triangle. I really don't know why. They just really don't want to draw it. And so that many times happens in errors. Draw the triangle. You should draw the triangle. So it takes like 2 seconds, right? We're going to draw a triangle. It's triangle A, B, C. Doesn't really matter where you start, the A, B, C, wherever. So it tells us that the side B is 5, so that's the side opposite angle B. Side C is 7. It's the side opposite angle C. And the measure of angle A is 39 degrees. So that's the information that we have. Basically what we have is side, angle, side. Right? That's what we have. We have side, angle, side. When we have side, angle, side, that means we want to use law of cosines. They're asking us to find side A. Okay, so law of cosines. So when we set up law of cosines, we have to really be aware. We need to be sure that the angle that we're using, that we start off with the side opposite. So A squared. Then it doesn't really matter what order we put the other sides in. So A squared equals 7 squared plus 5 squared minus 2 times 7 times 5 cosine of 39 degrees. Now let me point out a couple of errors that I was seeing earlier today. Sometimes students would use these two properly, the 7 and the 5, and then they would put a different side measure over here. These are the same, right? This side measure should match that side measure, that should match. They should match. You shouldn't have different numbers there. I have also seen occasionally where a student will use sine here. Okay, this is the law of cosines, right? It has to have a cosine there. It's its name, law of cosines. So be sure that you use a cosine. So for work purposes, I have to see this step. I have to see you plugging into the formula. Once I see you plug into the formula, I can just get the answer after that. You don't have to show me the intermediary steps. You can if you want to, but I have to have that first step. So we would plug this in our calculator, the 7 squared plus 5 squared minus 2 times 7 times 5 cosine 39 degrees. We're going to get a number. So I did that. We plugged into our calculator. I got, it's like 19.5997. We know we don't round. We leave it there. Right? We know no intermediary rounding. So now we're ready to square root. So we square root this number in our calculator. And we get that the measure of side A is 4.427. And that's all they wanted us to do, is find the measure of angle A. So that is our very first law of cosines. How was that? It's not bad, right? Okay, remembering the formula could be a little challenging, but that's just what we just have to memorize it. Okay, we don't really have a workaround on that. Okay, so let's take a look at our second one. So again, I'm going to draw the triangle, so it's X, Y, Z. Let's see what information we have. We know that X is 3, that's the side opposite angle X. We know that Y is 7 and Z is 9. Okay, in this particular instance we only have sides, so this would be side, side, side. And according to our guideline we should use law of cosines. Alright, so we're going to use law of cosines. Now since they want us to find angle Z, this is the one that we're interested in, that's how I'm going to, I think of these as anchors, right? The beginning and ending of this law of cosine is like the anchor, right? That's how it's based. These are the side and angle opposite each other. That's how it's built. And so since I want angle Z, I'm going to start my formula out with the 9 because I want angle Z. Could I start it with another one? Sure, but then I would have to do it again because I need angle Z. That's the one they want me to find. So let's go ahead and start that out. So we have 9 squared equals, then we'd have 7 squared plus 3 squared minus 2 times 7 times 3 cosine of Z. Okay, and I have to see that step on your paper. So now I'm going to do some algebra. Basically, I'm going to take the 7 squared and the 3 squared and move them over with the 9 squared. So, you know, like 81 minus 49 minus 9. I want to move that all to one side, and that gives me 23. Then I'm going to multiply the 2 and the 7 and the 3. Just kind of multiply those out, and that gives me, what, a negative 42 cosine of z. Okay, so now I'm going to solve for cosine z. So I have negative 23 over 42 equals cosine z. Now I'm going to go ahead and rewrite this as an inverse. Do you have to? No. I mean, you could leave it like that, but I'm going to go ahead and write it because I know in my calculator I'm going to be putting cosine negative 1 of negative 3 over 42 equals z. And if you mistakenly don't put the negative, it's going to give you a whole different measure. So you need to be cautious. So we put that in our calculator and we get that angle z is 123.2038. So we'll say 204 degrees. Okay, so now we've seen two different kinds of renditions of law of cosines. Are we okay with that so far? Yes? Okay. So let's take a look at the last example we have up here. Okay, I have triangle ABC. So measure of side A is 8. Measure of angle B is 64 degrees. And measure of angle C is 38 degrees. They want us to find C. Okay. So here we have angle, side, angle. Okay. According to our guidelines, we should be using law of sines. Okay, so remember those are little fractions, right? Really the only side that I have is this one. I really need the angle opposite it in order to set up my first fraction. You know, at least one of the fractions needs both the values in it. The angle measure and the side measure, or we're kind of messed up. We're going to have a system or something to deal with. That's going to be a problem. So I really need this. I don't have it, but I could certainly find it, right? I mean, we did have done that before. So if I take 180 degrees and I take out the 64 and I take out the 38, I mean, that's going to give me my angle A, right? So angle A is 78 degrees. Okay, so now I have my first fraction. So I have sine of 78 degrees over 8 equals. Now the one that I want to use is the angle opposite side C, because that's the one I'm interested in, right? I want to find side C. So I would need to set that equal to sine of 38 degrees over C. Okay, is everybody okay with that? And understand why I picked the ones that I did? Okay. So now I'm going to solve. I'm going to cross multiply. So I get C sine of 78 degrees equals 8 sine of 38 degrees. Okay, then I'm going to solve for C. So C is 8 sine of 38 degrees over sine of 78 degrees. And so I just put it in my calculator exactly like that. Just 8 sine 38 degrees over sine 78 degrees, exactly like that. And just hit enter. And then that gives me my side measure. My side measure is 5.035. 5.035. And that's law of sines. I think law of sines is, students tend to prefer law of sines because of the shortness of it and how easy it is. I just want to caution you that it doesn't always work. Actually, on your daily work, the first or second problem that you do, it's going to kind of walk you through the problems that law of sines will encounter. Okay, are there any questions for me? Do we know how to use both of those? Mm-hmm. Well, the sum of the angles is 180, right?
Oh, for the law of sine.
For the well, the issue with the law of sines is, so let's think about the principal values of sine. Where's the principal value? We only have two places where principal values are, right? We have the first quadrant, and where else does law of sines have its principal value? In the fourth quadrant. Where are all obtuse angles? In the second quadrant. It doesn't see them. Okay, and you're going to work through an example like that in your daily work, so that I'll kind of flesh it out, make sure you understand exactly what that means. Okay? All right.